All right, man. I received a message from Philip Pape, and he had a
Philip.
pretty good, yeah. Shout out to Philip over at Wits and Weights. He had a pretty good topic for us to talk about, and that's was kind of the different effects from different types of saturated fatty acids, and then like what are those sources coming from. So I thought, yeah, man, it's a good topic. He shared some others too, so we'll have some more going into the future. So let's talk about what these saturated fatty acids are, what they look like, and we'll get into debunking a little nonsense that goes around on the internet here right at the beginning of this. All right, so at the top here, we can see that this is stearic acid. This is a saturated fatty acid. And at the head of it, we have a hydrogen and an oxygen atom. Combined, we have an oxygen atom over here. And this equal sign represents a covalent bond. And the minus sign, that would be a double covalent bond. And then the minus sign right here is a single covalent bond. And throughout the structure of this saturated fatty acid here, we can see that this is a carbon atom backbone. And all along the outside on both sides of this are hydrogen atoms. Now, this is what we call a fully saturated fatty acid because all of the carbon atoms have hydrogen atoms bonded to them on either side. The north and south here, and then the east and west, the carbon atom is bonded to another carbon atom, and they all have single bonds. When we look at unsaturated fatty acids, now this is oleic acid. This would be, well, I'll show you here in a second. So this is an unsaturated fatty acid. And we can see that right in the middle here, these two carbon atoms don't have a hydrogen atom on the south side. And so what happens to those bonds is they move from the south side to the east and the west side, and we end up with a double covalent bond between these carbon atoms here. And that creates our unsaturated. So the carbon chain is not fully saturated with hydrogen atoms on both sides of it. Now this is, again, oleic acid. And so over here we have the hydrogen and oxygen, and then the oxygen atoms at the head. And at the tail end, this is the tail end. If we were to count from the last carbon atom, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oleic acid is omega 9 fatty acid. All right. And so if this was an omega 3 fatty acid, guess where that double bond would be? 1, 2, 3. It would be right here.
Yep.
Now, this molecule here in the boomerang shape is the cis configuration. This is a cis unsaturated fatty acid. Down here at the bottom, we have the same oleic acid, the same omega 9 mono unsaturated. There's only one double bond. If this was a poly unsaturated fatty acid, we would see more than one of these double bonds throughout this chain. But this is a mono unsaturated fatty acid. And here we have it in the bottom in the trans configuration. Now we can see that we are still missing a hydrogen atom, so this is still a mono unsaturated fatty acid. However, the structure of it is now what we call an isomer. And that just means that the chemical structure, the chemical makeup of it is the same, but the configuration has changed. And this now represents, this looks more like the saturated fatty acid on top. And that is where the health hazard comes into trans fatty acids, is that we hear a lot of stuff on the internet about how our body can't recognize X, Y, and Z. Most of that is bunk. However, when it comes to trans fatty acids, our bodies don't really recognize trans fatty acids. It doesn't see this as a mono unsaturated fatty acid. It sees it as a saturated fatty acid, and so it kind of uses it in the same way. And the way that saturated fatty acids, as we're going to get into, affect our health is by raising LDL. Okay, so there's a little meme that goes around on the internet here, that margarine is only one molecule away from plastic, and it shares 27 ingredients with paint. Now, whenever somebody brings this up, I always like to ask the question, which one? Which molecule are you talking about, and which plastic are you talking about? Because plastics aren't just one thing.
Yeah.
Right? We have ABS, we have ASA, we have PLA, we have PETG, we have TPU, we have PET, we have polycarbonates. There's all kinds of different things. So
that's way more plastics than I ever knew we had.
which plastic specifically is it, and which molecule is it specifically? Now, people don't know the answer to that question. So let's just get into what they're talking about here. So first of all, there is just a basic misunderstanding of basic chemistry. So the idea that it's only one molecule away, so the word molecule is being incorrectly used for atom. Okay, and what they see here is, so we can see, so monomer, so mono being one, poly being more than one, and we saw that in our unsaturated fatty acids. We have mono unsaturated fatty acids, which have one double bond, poly unsaturated fatty acids, which have more than one double bond. And then the monomer, so mer just stands for this repeating molecule here. And we can see we have a carbon backbone, and we have hydrogen atoms on either side of that, joined by a bond between carbon atoms. And then when we have a polymer, so this repeating sequence of this molecule here, right? We have a carbon backbone, we have hydrogen on both sides, and this looks very similar to our fatty acids, right? Mm-hmm. What the plastic is missing is the oxygen atom, not molecule. It's missing an oxygen atom. Okay, so the first thing that's happening is people don't understand basic chemistry, and they're confusing atom with molecule. And so if we look at this here, we see that this carbon chain is straight, and we see the hydrogen atoms on both sides. Now, if we go back to our example here, so this oleic acid, if we were to add another double bond down here at the 6, that would look more like linoleic acid, which would be omega-6, which is the one that's supposed to be bad. All right, and this would turn into kind of like a U shape, have a little U shape in it. It might even be a little bit more of a L to it. It'd be a little squiggly kind of a looking thing. But which one of these does our polymer, our plastic polymer, look more like? The saturated fatty acid or the unsaturated fatty acid?
Are you asking me?
I'm asking you.
Saturated.
Yeah. Looks more like the saturated.
Mm-hmm.
And then if we just go ahead and take a look at all of them, they all basically have the same atoms that make up the chemical structure of the fatty acid: oxygen, carbon, and hydrogen. So technically speaking, butter is one atom away from being plastic. If you know what I mean? If you want to go down that route, saying, well, it's missing an oxygen atom, therefore it's one molecule.
Per molecule.
Or one atom away. Yeah, per molecule. And this, again, is an individual fatty acid chain here. This doesn't even come into speaking about triacylglycerols or triglycerides. So, we won't even go there. But, on the basis that, well, this plastic is missing an oxygen atom, therefore butter or margarine is missing. Well, if that's the case, then so is butter. All right, and so let's talk about what happens when we make margarine. So we don't make margarine now the way that we used to. So most people would be familiar with hydrogenation, and that's the process that we used to predominantly use to make these solid. We take vegetable oils and we make a solid spread out of it. Mm-hmm. All right, and so we do that through the process of hydrogenation. And so basically, what we have here, we can see. On the left side, we have this double bond between our carbon atoms. And what we would do is we would add hydrogen to those double bonds at a certain temperature, and we would change that from, we see this unsaturated fatty acid to something that looks more like a saturated fatty acid. All right. And then as we start hydrogenating, so we see that on the top here, we have this L shape. This is our poly unsaturated fatty acid. We have more than one double bond. And as we start adding hydrogen to it, we start creating trans configurations. Now in this one, only in the middle structure here, only the one double bond changed to a trans configuration. The other one stayed as a cis. And at the bottom here, both of them changed to a trans configuration. And so again, as we, hydrogenate something, we create these trans configurations, which makes the structure of the fatty acid look more like a saturated fatty acid than an unsaturated fatty acid. Again, making it more like butter than the oil. And so even if we were to say, well, we have this molecule here, or this molecule here, these trans fatty acids, and maybe we're just not confusing the word molecule with atom, and we actually do require another molecule that we could add to this that suddenly makes it a plastic. Again, if it works for margarine, then it works for butter.
Absolutely. Yes.
Right?
Yes.
All right.
Yes. By the
So
way,
that's,
there's so many other products in our world that are one atom away from something else, and people just don't realize it. Just saying.
Yeah.
We've actually had this
famous
conversation before.
Yeah, water is one molecule away from hydrogen peroxide.
True, that's true.
The air you breathe, oxygen, is one molecule away from being carbon monoxide.
Yep.
Salt is one molecule and one atom away from being hydrochloric acid. So just because something is one atom away or one molecule away, it just shows an ignorance of basic chemistry.
Yeah, and it's campaign against margarine. It's just a campaign.
Yeah, it's just ridiculousness. And then the second part of that is that that meme, it shares 27 ingredients with paint. There aren't even 27 ingredients in margarine. So it can't... Or
That's
23
right.
or whatever number...
That's right.
Or is it 27? Yeah, it shares 27 ingredients with paint. There aren't even 27 ingredients in there. So it can't share 27 ingredients if it doesn't have 27 ingredients. And I guarantee you that paint does not contain palm kernel oil or canola oil or salt, like iodized table salt. It doesn't contain those things. Yeah.
Oh,
So,
that tickles me. Yeah, I used to mix paint when I was working in an auto parts store. I tasted a little bit of it, and it just tastes a little salty to me. So,
yeah. I mean, it's just nonsense. All right. So getting on with our regularly scheduled program here.
hit us. Let's do it.
So as we saw, our fatty acids have carbon chains. Okay. That's the backbone, which the hydrogen atoms will bond to, and these create our different saturated fatty acids, unsaturated fatty acids, and all that stuff. Now, the carbon chains come in different lengths. And so it's true that not all saturated fatty acids have a poor effect on health. Now, the main one being heart disease. All right. Other than that, there may be a little bit that we could talk about in another episode regarding insulin resistance. But I think there are a lot of factors that go into the insulin resistance thing. So the main thing we're concerned with is cardiovascular disease or atherosclerotic cardiovascular disease, whereby saturated fatty acid tends to raise LDL cholesterol. specifically ApoB. Now, it's not all saturated fatty acids. Really what we found is that there are two primary fatty acids. One is palmitic acid, the other one is stearic acid, and those are the saturated fatty acids that we found tend to raise LDL the highest. And so without, going into 15 different studies here, so we have a great systematic review here, shows us that long-chain saturated fatty acids being of a carbon length, so the number of carbon atoms on that backbone being 12 to 18, increase the risk of cardiovascular development, while some of the shorter chain fatty acids and the medium chain fatty acids, people might be familiar with these, a lot of selling going online of medium chain triglycerides people are putting in their coffee and stuff. Those things may be more beneficial to neutral.
I haven't heard of that.
You never heard of the medium chain triglyceride?
No.
MCT oil?
No. Putting in my coffee?
Oh.
No.
Yeah, basically coconut oil.
Ah.
Yeah.
There you go. Got some coconut.
We're going to look at that as well.
Maybe some
All right,
chocolate.
so yeah, the main sources of these saturated fatty acids were the carbon-16 and the carbon-18, the palmitic acid and the stearic acid. In most of the studies in this review, so 3 of the studies, carbon-4 to carbon-10 had no link for cardiovascular disease. And there was even a reduction of risk for ischemic heart disease found for those in the Pragman et al. Here. Now, where is the saturated fats coming from? Most of the saturated fats, particularly in the American diet, come from dairy products. That's our main source of saturated fatty acids. In the review here, they came from cheese, milk and milk products, meat, fats, hard or solid, and that could include some margarines and stuff, but also would be like lard, butter. Butter is a separate thing.
Cheese.
But I got cheese over here.
Okay.
So main sources of fatty acids coming in the American diet: red meat and high-fat dairy products, that being cheese and butter. All right. Low-fat poultry and fish. The fats from those were linked to lower risk of cardiovascular disease. And then in purple here we have another study reported that butter, milk, and cheese had a significant reduction in risk on ischemic heart disease. And in the EPIC Norfolk cohort, they found no statistical significance with meat, dairy, cheese, soft and hard fats, cookies, cakes, and isocaloric substitutions. We're going to talk about that. Why are there studies that show no association between saturated fat and heart disease? In general, most of the studies in the review here found that long-chain saturated fatty acids, that carbon-12 through carbon-18, may increase the risk for CVD, while short-chain and medium-chain may be more beneficial or neutral. However, researchers report difficulty distinguishing between individual saturated fatty acids because most food sources contain multiple types of saturated fatty acids. And that's why our dietary recommendations are what they are. Just try to reduce saturated fat overall.
Right.
Because it's really hard to, right? The average person isn't going to be going around looking for, okay, well, what carbon length of saturated fatty acid is in this versus this, right? So the goal is just to reduce saturated fatty acid intake overall, and the recommendations by the dietary guidelines is to keep it under 10%. Now, I talk about replacements. So replacement of macronutrients for saturated fatty acids may play a larger role in the development of cardiovascular disease than the saturated fatty acid itself. Now, this sentence goes into the reason why certain studies will or will not find an association between saturated fatty acids and cardiovascular disease. Because what are we comparing it to? What are we replacing it with? If one decreases saturated fat intake, what does one replace it with? When it comes to polyunsaturated fatty acids, we find that replacing saturated fatty acids with polyunsaturated fatty acids tends to have the largest effect on cardiovascular disease reduction. Monounsaturated fatty acid would be the next. Whole grains would be the next. And we really find no difference and maybe even a slight increase when we replace saturated fatty acids with refined carbohydrates and processed sugars. The effect of coconut oil consumption. So we talked about these medium chain triglycerides, right?
Right.
And that they're finding maybe a neutral to no benefit. So the idea then is that, well, then plant sources of saturated fatty acids are probably beneficial for us or have no effect. And therefore, coconut oil tends to get this health halo put around it because it has a lot of medium chain triglycerides. So is it really true that coconut oil, may reduce your risk of cardiovascular disease or has this health halo? And in this trial here, they found that coconut oil significantly increased LDL cholesterol by 10.5 milligrams per deciliter compared to vegetable oils. And interestingly, in this trial, so we can see here on the right-hand side of the null line, so our zero line right in the middle, and we have coconut oil increases LDL cholesterol on the right, and we can see the vast majority of these, this is meta-analysis, not a trial. Vast majority of these trials, coconut increases LDL cholesterol, come down, and again, and we have our diamonds, so this is our net effect size of all of these studies combined, and all of them are to the right, and they are all statistically significant, meaning there's a small, almost no chance that the results of these trials are due to random chance. All right, so they did find an increase by 10.5 milligrams per deciliter compared to vegetable oils. Compared to palm oil, they found it was increased LDL cholesterol by 20
Wow.
milligrams per deciliter.
Wow.
So that was, that's quite an interesting little shock there because we tend to hear that palm oil is like the worst thing ever. But as far as raising LDL, coconut oil in this meta-analysis showed that coconut oil raises LDL more than any other. All right, now I've brought this up very briefly before. We talk about the fact that there may be reviews, meta-analyses, or individual studies that find no correlation between saturated fatty acids and heart disease or cardiovascular disease, whatever the case may be.
Right.
And we have to ask the reason why. So number one, as we saw, what is the saturated fatty acid being compared to in those papers? If it's being compared to, or the replacement is processed and refined grains and sugars, of course we're not going to see any difference.
Right.
That's established in the literature. All right. The second thing is, are they making adjustments for cholesterol? And we'll find that a lot of meta-analyses, there's a couple of them that are popular that float around that show no association. Actually, like about 40 to 45% of the weight of those meta-analyses are from trials that adjust for cholesterol, blood cholesterol levels. And so what's happening there is, Dwayne, let's say that I did a meta-analysis and, or I'm not doing a meta-analysis, but I'm looking at epidemiologic data on gun violence, and I want to find out if guns have a high correlation with deaths in murder cases or whatever, right? And so I pull a bunch of data and I look at it and I come to you and I say, Dwayne, I found that there's no association between guns and murder in a lot of these violent crimes. Would that be surprising to you?
Yeah, a little bit.
A little bit, right?
You would say,
how did you come to that conclusion? And I would say, oh, well, what I did is I adjusted for the bullets. I removed the statistical effect that the bullet has on mortality. And so what we're left with are events where people were bludgeoned to death with the gun. And those events are quite low and rare. And, when we add that all up in all of the data that we have, we would see no association between guns and mortality in these violent crimes.
Yeah, I would just like to interject here. I'm sorry.
Yeah.
I would like to interject here that whenever that has happened, whenever that adjustment happens, and I've preached about this before because I have some knowledge in this, when you make that adjustment, oh, well, we just adjusted for bullets. When you make those adjustments, there's a purpose. There's a purpose. You don't just go, hey, we should just make these adjustments and see what happens. There's a purpose. That's all I'm going to say, is when you start making
Right.
adjustments, there is a reason.
And yes, and if we are, so there's a desire from
Yes.
the pro
Yes.
saturated fat community to try and establish a direct link between saturated fat and cardiovascular disease.
Yes.
Well, that's not there. The way that saturated fat increases cardiovascular disease is by raising LDL. So saturated fatty acid reduce LDL receptor activity, thereby kind of backing up the system with LDL cholesterol. So if you think about LDL cholesterol as being a container ship coming into the port, which is the liver, to drop off its cargo, and the LDL receptors are crane operators who are unloading the ship. If we reduce the number of crane operators in the port, we're going to see a backing up of cargo ships.
Yep.
Right?
That's a great analogy, by the way.
So that's how saturated fatty acids affect it. And if you are removing the statistical effect that LDL cholesterol or total cholesterol has in your model, you are removing the thing by which we see a causal mechanism for cardiovascular disease.
Right.
Just like in the guns and the bullet cases, if I remove the bullet from my statistical model, I am removing the thing, which is the causal factor for mortality.
Yep.
All right. Now, this trial, we saw this when when we did the food pyramid show, and Jordan Peterson likes to cite this trial a lot. And again, nothing against Jordan Peterson. But let's look at this thing. All right. So he said, and a lot of people online will do this too.
This is the 18-country, 5-continent prospective cohort study.
Yeah, this is the PURE trial. 18 countries from 5 continents. And their findings in the abstract, intake of total fat was associated, and each type of fat was associated with lower risk of mortality. Saturated fat, we're seeing here, there was a 14% reduction in total mortality. And they see higher saturated fat intake associated with lower risk of stroke. This is quintile 5 versus quintile 1. So the most amount of saturated fat versus the lowest amount. And then total unsaturated fat and unsaturated fats were not significantly associated with risk of myocardial infarction or cardiovascular disease mortality. And at the conclusion here, they have the interpretation down here. High carbohydrate intake was associated with high risk of total mortality, whereas total fat and individual types of fats were related with total mortality. Total fat and types of fat were not associated with cardiovascular disease, myocardial infarction, those are heart attacks, or cardiovascular disease mortality, whereas saturated fat had an inverse association with stroke. Global dietary guidelines should be reconsidered in light of these findings. Now, before we get into this, again, the global dietary guideline, we look at all across all different populations, different countries, different recommendations coming from different countries. Keeping saturated fat below 10% of energy seems to be the common recommendation. That's
Right.
about where it is, somewhere around
Absolutely.
10%.
Right.
So if this study shows that higher intakes of saturated fat are not related or not associated with cardiovascular disease, people automatically have in their mind, well, this obviously is showing 25%, 30%, somewhere up in there. What would your guess be, Dwayne?
25. That's what they would be saying.
25. So, yeah. So in order to say, listen, we need to reevaluate the dietary guidelines, the highest amount of saturated fat consumed in this paper has to be well above the recommendations, which is 10%.
Yeah.
So let's scroll on down and see what it is. So our countries, we have China, South Asia, Europe and North America, South America, the Middle East, Southeast Asia, and Africa. And we see our energy from fat. Now our recommendations, dietary guideline recommendations, keep total fat around 30%. And we can see that the highest amount here coming from Europe and North America is 30.5%. And then we have the Middle East, which is at 30, Southeast Asia at 29, and the rest of them start falling off from there. Energy from saturated fatty acids, the highest amount is 10.9. Let's just call it 11.
Yep.
Coming from Europe and North America. And then we have the Middle East at 10.2, and then it starts falling down from there. So right here on its face, Dwayne, so the highest amount consumed, this is the mean, is 11%.
Mm-hmm.
Is 11%, this is the highest amount of saturated fat. Is that closer to the current recommendations?
Absolutely.
Yeah.
Absolutely.
Yeah.
Absolutely.
Like if the recommendation is 10% and the amount we see consumed, the mean is 11, then this paper does not support the notion that guidelines should be reconsidered. And then coming down here, so we have these hazard ratios for total mortality, major cardiovascular disease, MI, stroke, all this stuff. And remember, comparing quintile 5 to quintile 1. So we have quintile 1 on the left highlighted in blue, quintile 5 on the right. And again, our recommendations are to keep total fat somewhere around 30 to 35%. I actually think it's 30 to 40%. And we see here that the quintile 5 is 35%, which falls right in line with current recommendations. We scroll on down to the individual fatty acids. So percent of energy from saturated fatty acid, the lowest amount is 2.8, quintile 1, and quintile 5 is 13.2. Now, is 13.2 more in line with the current recommendations, or does that suggest we need to reevaluate everything?
No, it's pretty darn close. Absolutely.
No. This does not suggest at all that a diet consisting mainly of ribeyes and butter is more supported by this paper than the current guidelines. If anything, this paper thoroughly supports the guidelines. The other thing that we need to look at, Dwayne, here, I said it in the where are these countries coming from? This is China, South Asia, South America, Middle East, Southeast Asia, and Africa.
Yeah.
Poverty-stricken countries or exceptionally wealthy countries, Dwayne?
Predominantly poverty-stricken.
Predominantly poverty.
Africa, Southeast Asia. So there's not a lot of crap to eat for them. I'll just say, sorry.
Yeah.
Just slipped right out.
So considering the populations, and then if we were to actually go in here and look at percent of carbohydrates, so we can see in China it's 67%, 65%.
Yeah.
So the main staple in these countries would be white rice.
Yeah. Yeah.
So the other thing that we can take away from this is it's probably better to live in a country where you have access to a variety of different foods rather than having white rice as the main staple in your diet, which is probably going to leave your diet nutritionally deficient, right, where any amount of saturated fat is probably going to increase the nutritional adequacy of that diet.
Right.
All right. So concerning our saturated fatty acids and their effects, which is mainly going to be cardiovascular disease, we find that saturated fatty acids will tend to raise LDL more than unsaturated fatty acids. Right. Saturated fatty acids are what we consider to be solid at room temperature.
Right.
Unsaturated fatty acids would be oils. Now, there may be the idea that, and a lot of the carnivore folks like to throw it around is that, well, there's less saturated fatty acid in red meat than you think because 50% of the fat is coming from monounsaturated fatty acids. And when we think about monounsaturated fatty acids, we tend to think of stuff like olive oil and some sources of dairy, but mainly we see healthy effects coming from monounsaturated fatty acids. And the problem being is that when we look at the difference on outcomes between animal sources and plant sources of monounsaturated fatty acids, we tend to see that for monounsaturated fatty in the green here, monounsaturated fatty acids from animal sources, we see an increased cardiovascular risk when you substitute the monounsaturated fatty acids from animal sources for saturated fatty acids. We get an 11% increase. No, a 4% increase from saturated fatty acids and 11% for refined carbohydrates. And then we have that 0.88 for trans fats. When MUFAs from plant sources are modeled to isocalorically replace other macronutrients, so this is where we are replacing saturated fat with a monounsaturated fat from a plant source like olive oil. We see a reduction in risk there of about 17%. For refined carbohydrates, we see a reduction in risk of about 14%. And we do trans fats, we see about a 20% reduction. And then when we replace animal sources of MUFAs with plant sources of MUFAs, we see a similar reduction in risk. So where the monounsaturated fatty acid is coming from is important as well. And unfortunately, we've talked about it multiple times, this is what the data says.
Yeah.
This is what it is.
Yep.
I am terribly sorry, but it does seem to be the case that animal sources of saturated fatty acids are particularly harmful, whether they're saturated fatty acid or monounsaturated fatty acid. Now, we do see a small paradox, so to speak, in the terms of dairy. So things like milk and yogurts and hard cheeses, we really tend to see a neutral to a slightly beneficial effect from those. Now, the problem being, again, is when we are replacing that to what? So when we are replacing something like butter or the fat from a ribeye, and we're replacing that with saturated fatty acid from cheese or yogurt or something, we'll tend to see a positive effect or maybe a neutral effect. But when we compare those fats from yogurts, cheeses, and other hard dairy or other dairy sources to plant sources of those same types of fats, we tend to see that dairy does worse. So, but overall, if you were to include some of those things, yogurts, kefir, some of the milks and hard cheeses, it probably will have a beneficial effect on most people's diets. I forgot where my brain was going there.
Well, while you're thinking about it, I'm just going to take like a mile leap backwards out of side of the complication ring there, and just remind people that, man, sometimes it's just common sense. What things they put in your body, if they're good for you or not. And I love a ribeye steak from time to time, but if you take one home from a restaurant, or if you cook your own, you don't eat it all and you put it in the refrigerator and you take it back out and you haven't trimmed the fat off of it, and you look at that, do you really want to eat that? That's nasty. That's nasty. I don't want to put that in my mouth. So, I mean, if I eat a steak like that, I trim all that fat off, even if it's marbled in there. If I can get all the fat out of there, I'm going to do that, because I don't want to look at that the next day.
Yeah.
Don't get me started on beef tallow either. So.
Yeah.
Sorry.
Yeah. And
When it becomes a solid, that is not. It just makes sense.
Yeah.
That wasn't meant to be in there. Don't eat that.
Yeah, it's it's tasty for sure, but
When it's
all right.
liquid.
So without without having to go through, 50 to 75 studies and showing everything. So I brought up just the Pure trial because that is quite a popular one that floats around saying, well, the people who consume, out of these 18 different countries over 5 continents, the people who consume the most amount of saturated fatty acid, we can see that the body of literature, when we actually get into it and we look at the amounts that are in there, actually supports the current guidelines more than not.
Right.
And you'll hear a lot that, well, there's no evidence for the dietary guide. Well, the Pure study is evidence for the dietary guidelines. All right, and a lot of the other
they do support the dietary guidelines. Absolutely.
yeah, and a lot of the other trials that you'll see that will claim we need to reevaluate the guidelines in light of this evidence. It supports the guidelines that more than the notion that we should be eating 70% of our energy from fat sources, and most of that being saturated fat. There is almost nothing that supports that idea. You are making huge leaps in logic to draw those inferences, and people just are not reading the studies.
Right.
All right. So our saturated fatty acids, really it's palmitic acid and stearic acid. However, it's kind of just like unless you're going around, looking up the specific quantity of those carbon chain lengths in each fat, our recommendations are keep your saturated fat below 10%, somewhere around below 10%.
Yep.
Vast majority of people are getting their saturated fat from dairy products. However, they're not always the healthy dairy products that are associated with lower risk, right? So people are eating tons and tons of butter and cream, heavy cream, and these softer cheeses. The softer cheeses and stuff don't have the same cardiovascular risk factor that the harder cheeses do. And a lot of people, point to Italy. Well, they're not eating Kraft singles in Italy, my friend. You know what I mean? So,
That's funny you say that.
Hard.
That's funny you say that. Because I was just thinking something else. Where there's a lot of saturated fats too? I mean, not as much as like in fatty cuts of meat or stuff like that, but like cheese crackers and some popcorn. When I found that out, I
Put
thought,
cheese on popcorn?
no, some cheese crackers.
Yeah.
Like those little orange cheese things that have the peanut butter in there.
Oh yeah.
Those puppies are loaded with saturated fat. Not as much as a steak or a ribeye or something, but it's in there.
A vast majority of it is going to be like
cheeses and
Mexican shredded blend. We're eating on our pizzas.
Yep.
And you get the slices of cheese on your burgers and stuff when you go through McDonald's drive-thru.
Yep.
Those, and then people are drinking whole milk. And
absolutely.
What's the other one? But anyway, those are not the same. So those are the problematic sources to include butter. Ghee is even worse. Don't think that because you're making a saturated fatty acid even more saturated fatty acid.
Yep.
So the harder cheeses like Parmesan, some of the harder cheddar cheeses, even though those are a little bit soft. And then you have things like kefir and Greek yogurt or skyr. Those are the sources where we find the benefits. It's not
right.
It's not typical American cuisine sources of dairy.
Right.
So that's, those are the reasons why we get the recommendations that we do. And then coconut oil does not have a health halo around it. Coconut oil does tend to raise LDL cholesterol. You absolutely can develop cardiovascular disease from consuming a whole bunch of coconut oil. So use all of these things sparingly. Not to say that you can't cook with butter or ghee or coconut oil. Use them sparingly. Try and reduce your saturated fatty acid intake, as much as possible. And if you're able to get it down below 10%, hey, great. Other than that, That's about it.
Boom.
Boom. All right, well, hope everybody got something from that. Hope I didn't put you to sleep. Margarine is not one molecule away from plastic, and we will see you guys next time. Coach Lambie and Dwayne out.
See you guys.